All right, what's up guys? Mr. Fabella here. Day, I don't know how many of trying to wear a soccer jersey every day that I'm gonna make a video. So you think, oh, Mr. Fabella, how many Liverpool jerseys could you have? I don't know, we're about to find out. But today we're going to do the area of composite figures. So, and that includes the area of maybe a shaded region. Definition of a composite figure, I'll put it somewhere up here. So basically, a composite figure is more than one shape all into one. So here's a couple of examples of composite figures right here. That would be a parallelogram and a rectangle. This would be a trapezoid and a triangle. If you have ever done tangrams before, that's an example of a bunch of different composite figures. But tangrams actually they all have the same area if you use all of them. So I did composite figures. I did a video also for my 6th grade class, but that did not include circles. It might have done some trapezoids as well, but it was a little at a 6th grade level. So here we're doing 7th grade pre-algebra stuff, so I decided to make a total separate one, but I will link it up there and in the description below. So let's start off with some composite figures. So here it says, find the area of the composite figure right here. This is almost looking like an ice cream cone, but not. You can obviously two shapes there. So you have, and I'll split it up for you right here, you have a semicircle, which is half of a circle, and a right triangle. So now that I split those up into two separate shapes, all you need to do for a composite figure is find the area of the semicircle, find the area of the triangle, and add them together. So just for sake of being clear, I'm going to say area of the semicircle plus the area of the triangle will equal the area of that figure, right? So let's do area of the semicircle first. If you recall, the area of a circle is pi times the radius squared. Semicircle is half of that, so 1/2. It didn't say what to use as pi, so I'm just going to use 3.14. So 1/2 times 3.14 times the radius squared. So this is a mistake that I see a lot of people do all the time. The radius of this circle is not 6. The radius is 3. Because if it says 6 right there, that's talking about the entire diameter. So that means the radius is 3. So I'm going to put 3 squared. And then now you just work this out using order of operations. I have to do the exponents first. And then you could just multiply straight across. And then you can use your calculators here if you want. So that's going to be 14.13. It didn't say it around, so that's in meters squared. All right, but you're not done. You need the area of the triangle. So area of the triangle, if you recall, is 1/2 base times height, or base times height divided by 2. All right, so base times height, the base and the height are perpendicular to each other, so it's going to be 6 and 11. So 1/2 times 6 times 11, and then you just go from left to right because it's all multiplying. So 3 times 11 is going to be 33 square meters. And so now we're going to follow what we said we're going to do up here, and we're going to go 14.13 plus 33, and that's going to be 47.13 square meters. Okay, right here I tried to enlarge this. It's a picture of a miniature golf hole. Okay, so they split this up into a couple of different pieces. This might be a little confusing because of this part right here. It's not splitting it up there, it's just saying that this red dotted line is perpendicular to that part right there. So hopefully that's not too confusing. Like, it doesn't split it up into here and here. That's not what it does. It's just saying that this is perpendicular to that. So if you remember what a parallelogram is, this is a parallelogram. So this is going to be the base, and this is going to be the height. Okay, so let's split that up into these two pieces here. So as you can see here, you have this region right there, which is a trapezoid. So right there. And then you also have this parallelogram that I was talking about right there. So you have a parallelogram and a trapezoid. So the area of this whole thing is going to be area of the trapezoid plus the area of the parallelogram. Okay, so you're going to have the area of the trapezoid, which I'll do in purple, plus the area of the parallelogram. All right, so let's work with the area of the trapezoid first. Now, we didn't do a full lesson on area of trapezoid. So area of trapezoid, if you forgot what it is, I'll put it here, but I know for a fact that you guys did it in 6th grade because I just made a video on it for the 6th graders. So area of a trapezoid is going to be 1/2 in parentheses base 1 plus base 2 times the height. Okay, so if you're confused about that, the bases of a trapezoid, so first of all, to have a trapezoid, you need 2 sets of parallel lines, or just 2 parallel lines. So these 2 lines, these 2 sides are parallel, but not the other sides. Because if the other sides were also parallel, then it would be a parallelogram. Here, if it's a quadrilateral, 4-sided figure with 1 pair of parallel sides, then you have a trapezoid. Okay? Then those parallel sides, those are the bases. This is base 1, and I can call that base 2. It doesn't matter what order you do it in. And then perpendicular to the 2 bases, that would be the height. So since over here, right around there, it said that was a 90-degree angle. This is a 90-degree angle. This is a 90-degree angle. That means the height is 3 feet. Right? And then you just fill everything in. So 1/2 times base 1 is 2 plus base 2 is 3 times the height, which is also 3. And then you just, this is going to be 7.5. And let's say square feet. So now let's do the area of the parallelogram. Area of the parallelogram should be a lot shorter because if you recall, area of the parallelogram is just base times height. And the base is always perpendicular to the height. This one's a little tricky because it gives you 2 figures. It says 3 and 2.5 and 6. So you're gonna have to figure out what the base and height is because there's an extra number there. So the base is perpendicular to the height. So perpendicular means at a 90-degree angle. So here, 2.5 is perpendicular to 6 feet. So the base I'm going to say is 6, and the height is 2.5. The 3 is not used for the area. It's going to be used for the perimeter if we ever wanted to find it. Okay, so here that's 12 plus 3 is 15. All right, so that's 15 square feet. All right, but again, we're not done. We're going to fill it in to what we said it was going to equal. So this is 15 over here and 7.5. So if we add those up, so you would get 22.5, and this is area, so feet squared. Okay, moving right along. Right now we have this figure. Okay, so that's not anything that we know how to find the area of right now. That's a octagon. There's actually several ways to do this. There's like 3 ways that pop up automatically. Maybe the not so common ways would be to split it up into 2 trapezoids and 1 rectangle, or 2 trapezoids and 1 rectangle this way, or even something like 1, 2, 3 different rectangles and 4 triangles and add them all up. But I'm guessing that you're thinking, no, Mr. Bella, that is not the way you're supposed to do it. So what I'm going to do is actually not add, I'm going to subtract. I'm going to go ahead and find the area of the rectangle, area of this big rectangle right here, okay? And then I'm going to subtract the area of these 4 triangles. And they do look like they're exactly the same on all of them if you look at these measurements. So there are 4 of them, so I'm going to say minus 4 of the area of the triangles. Let's do this. Let's get organized. This is like step 1 of doing compound figures or composite figures, is to get organized. Otherwise, you're going to forget stuff and you're going to put the answer too early. Area of the rectangle is going to be length times width, and that's pretty straightforward there. It's going to be 12 times 5, so that's 60 square inches. And then area of the triangle is going to be 1/2 base times height, right? But then it says 4 of them, so I'll just do it right at the beginning. So I'm going to say 4 times 1/2 base times height, so 4 triangles. Okay, so 4 times 1/2 times base and height of a triangle. So over here, you have 1 inch by 1 inch, and it doesn't say it's a right angle, but we're going to assume it's a right angle. So the base and height are 1 and 1. Okay, this looks pretty straightforward here. 4 times 1/2 is 2, times 1 times 1 is just 2. 2 square inches. Now we're going to fill all of these in to our original equation. So I'm going to bring this over here. Okay, so our original equation was that. If we have that, 60 minus 2, that's going to be 58 square inches. Okay, so that was a few examples that I want to give to you. I did actually go to Dwyer the other day and took a drone shots of that, and I actually tried to find the area of the main building. So I'll link another video, maybe up here somewhere, on the area of Dwyer. And also, earlier I said I did a 6th grade video for more kind of more simple shapes, and I'll link that as well. So hopefully that was helpful on composite figures, and I'll see you guys next time.